give you show you how to solve this quiz, which was not so hard, I hope. So we had this series, and I told you I had to use a ratio test, so let's right away do that. I remind you what the formula is. It's an plus 1 an. So in this particular case, let's work this out again. The absolute values are no longer necessary because everything is positive. Okay. There are no x's here, right? This is different because if we do with power series, we have x's, but here this doesn't happen. Okay, so we have 3 to the n plus 1 factorial 2 to the n. Now on top we get the same thing, except we're going to replace n by n plus 1, but to show you how to do it, I'm going to work it out again. N plus 1 factorial 2 to the power n. And so now this n should be n plus 1. And this n should be n plus 1. And also, what about this inner one? Well, the same thing. Sorry. So this n should be n plus 1. N plus 1. So in the top we get n plus 1 to n plus 2 factorial. That's the only thing perhaps that could throw you off a little bit here. Okay, so limit for n going to infinity, put everything as a simple fraction. So we have on top 3n plus 1, and also this denominator here, n plus 1 factorial, and 2 to the n. And in the bottom we get this n plus 2 factorial, this guy, 2n plus 1, and of course also this guy, 3 to the n. And then, quite simple, these guys cancel and I have a 3 left. The highest power is on top, here the highest power on the bottom, so I leave the 2 there. I prefer not to have negative exponents. Okay, so the only thing that had to be done here is rewrite n plus 2 factorial, the biggest one, in terms of the smaller one, n plus 1 factorial. So you ask yourself, what do I have to do to go from n plus 1 factorial to n plus 2 factorial? Well, it's only one step from n plus 1. What is missing is the factor n plus 2. And that's it. Okay? So, what we have, the limit for n going to infinity, we have a 3. The n plus 1 factorial, that's the smaller one, so we're going to keep that one. Then in the bottom we have a 2, I'm going to write it in front, and we have also n plus 1 factorial times n plus 2. That's using this here. Okay? The whole goal of this is that these factorials actually disappear, and that's why these limits of the ratio test is so nice. Factorials are very difficult to take limits of, but if you do the ratio test, they cancel out, and so you get actually simple things. And this is very easy, because if I plug in infinity, I get 3 over 2 times infinity, which is actually 0. The 3 and 2 don't matter here. And that's it. Well, that's it. It means it's less than 1. Well, don't forget to make this conclusion, so it is convergent. Okay, that was a simple